Have you ever wondered what happens when a star dies? But before we dive into the end, let's start at the beginning. Stars begin their life in the cold, vast expanses of space, birthed from immense clouds of gas and dust known as nebulae. Gravity, the great cosmic architect, begins its work, pulling these materials together. As these particles of gas and dust collide and compress, the core of the star-to-be starts to heat up. This process, known as accretion, continues until the core gets hot enough to trigger nuclear fusion, setting the heart of the star ablaze. Nuclear fusion is the powerhouse of a star. It's like a gigantic, never-ending explosion where hydrogen atoms collide and fuse to form helium, releasing colossal amounts of energy. This is what makes a star shine, casting its light across the cosmos. Now that we know how a star is born, what happens when it reaches the end of its life? Every star has a life cycle, much like living organisms on Earth. To begin with, our star in the making is a mere cloud of dust and gas, also known as a nebula. With gravity pulling everything inward, the nebula begins to collapse on itself, and the center becomes dense and hot, giving birth to what we call a protostar. Our protostar then grows by accumulating more and more mass from its surrounding nebula. As the pressure and temperature at its core rise, hydrogen atoms start to fuse together, releasing a tremendous amount of energy and light. And voila! Our protostar has now graduated to a full-fledged star, entering the main sequence phase, which is the longest stage of a star's life. The star now burns bright and steady for millions to billions of years, depending on its size. The larger the star, the shorter its lifespan because it burns through its nuclear fuel much faster. As the star exhausts its hydrogen fuel, it begins to expand and cool down, transforming into a red giant or a supergiant. The star's core contracts, while its outer layers inflate, and it begins to glow a brilliant red. A star's journey is one of constant transformation and evolution, fueled by the delicate balance between gravity and nuclear energy. Each stage of this celestial journey is a testament to the awe-inspiring processes that shape our universe. So, what happens when a star exhausts its nuclear fuel? One of the most popular theories about the end of a star is the supernova theory. Imagine a star burning bright and hot, a celestial furnace fueled by nuclear fusion. Over time, the star exhausts its fuel, and the dance of nuclear reactions slows down. With the pressure from these reactions dwindling, gravity gets the upper hand, causing the star's core to collapse under its own weight. This catastrophic collapse triggers an explosion of epic proportions, a supernova. In the blink of an astronomical eye, the star releases an unimaginable amount of energy, outshining entire galaxies for brief moments. But a supernova is more than just a grand cosmic spectacle. It's a celestial crucible, where elements heavier than iron are forged. The explosion disperses these heavy elements throughout the cosmos, stardust scattered far and wide. This cosmic dust, enriched with the building blocks of planets and life, drifts through the vastness of space. Over time, it may coalesce to form new stars and planets, seeding the universe with the potential for life. Supernovae play an essential role in the cosmic cycle of birth and death, creation and destruction. They mark the end of a star's life, but also the beginning of something new. Yet this grand finale is not the destiny of all stars. Some stars, depending on their mass and composition, follow a different path. But not all stars end their lives as supernovae. Another theory suggests that some stars end their lives as white dwarfs. Now this is where things get truly fascinating. You see, a white dwarf doesn't just appear out of nowhere. It forms when a medium-sized star, much like our sun, exhausts its nuclear fuel. Once the fuel is depleted, a series of events unfolds. The star begins to shed its outer layers, much like a snake shedding its skin. This shedding of layers is not a quiet affair. It produces a cosmic spectacle known as a planetary nebula, painting a brilliant picture across the vast canvas of space. The core that remains after this dramatic shedding is what we call a white dwarf. Now, you might think that a dwarf would be small and insignificant, but that's far from the case in the realm of stars. White dwarfs are incredibly dense. Imagine trying to squish the mass of the sun into the Earth's volume. That's the kind of density we are talking about. Over the course of billions of years, these white dwarfs cool down and their glow fades. They eventually become black dwarfs, celestial bodies that are theoretically invisible to the naked eye. But here's a question to ponder over. What if a star is too gargantuan, too massive to become a white dwarf? So what happens if a star is too massive to become a white dwarf? Some stars, too massive to become white dwarfs, end their lives as neutron stars. This is the fascinating next chapter in our cosmic tale. Neutron stars are formed from the collapsed core of a massive star, left behind after a supernova explosion. Imagine a stellar behemoth burning bright and furious, suddenly erupting in a cataclysmic blast. What's left is a dense, collapsed core, the heart of the former star, now a neutron star. These celestial bodies are a marvel of the universe in their own right. They're incredibly dense, with a teaspoon of neutron star matter weighing about 1 billion tons, equivalent to a mountain. Yet they are also incredibly small, with a diameter of only about 20 kilometers. That's like squeezing twice the mass of our sun into a city the size of Manhattan. One of the unique attributes of neutron stars is their rapid rotation. These stars can spin up to several hundred times per second. This rotation, combined with a strong magnetic field, emits beams of electromagnetic radiation. When these beams sweep past Earth, we observe them as pulses of radiation, making the neutron star appear to blink on and off, a phenomenon we call a pulsar. So you see, even in death, stars continue to astound us with their complexity and beauty. But the end of a star's life can be even more dramatic. So stick around as we dive deeper into the mysterious realms of the cosmos. The most massive stars in the universe may end their lives as black holes. A black hole, an entity as mysterious as it is powerful, forms when a star, having exhausted all its nuclear fuel, succumbs to its own gravity and collapses. This collapse compresses the star's mass into an infinitesimally small space, creating a singularity, a point where all known physical laws cease to apply. Around this singularity, an invisible boundary forms known as the event horizon. Beyond this boundary, the gravitational pull is so strong that nothing, not even light, the fastest thing in the universe, can escape. This is why a black hole is black. It's a region of space from which light cannot escape, rendering it invisible to our eyes. Black holes, although seemingly destructive, play a significant role in the universe. They can influence their surroundings in profound ways. Their intense gravitational pull can draw in nearby matter, creating an accretion disk of swirling gas and dust. This process can trigger the birth of new stars. Furthermore, when two black holes merge, they send ripples through the fabric of space and time, creating gravitational waves that we can detect here on Earth. Black holes are more than just the end stage of a star's life. They are cosmic laboratories, testing the limits of our understanding of the universe and challenging our theories of physics. These theories give us a glimpse into the fascinating life of a star. The life and death of stars have profound implications for the universe. Stars, in their fiery existence, are not just celestial bodies that light up the night sky. They are cosmic forges, crafting the elements that make up everything we see around us. From the moment a star is born, it begins a process of nuclear fusion, converting hydrogen into helium. This process releases energy in the form of light and heat, making the star shine. As the star ages, its internal furnace gets hotter and heavier elements like carbon, oxygen, and silicon are forged. But the real magic happens when a star dies. In the explosive death throes of a supernova, the star scatters these elements across the universe. This stardust, enriched with heavy elements, becomes the raw material for new stars, planets, and even life itself. In essence, the universe recycles itself. The death of one star contributes to the birth of others. Stars are like cosmic seeds, spreading the ingredients of life throughout the universe. They create, destroy, and recreate in a perpetual dance of stellar evolution. The next time you look up at the night sky, remember that each star is on a fascinating journey. A journey that not only illuminates the cosmos, but also creates the building blocks of life, and potentially, life itself. Each twinkle is a testament to the incredible recycling engine that is our universe. Today, we've journeyed through the life of a star and explored some fascinating theories about their end. We've witnessed the birth of a star, a cosmic spectacle of gas and dust coming together under gravity's relentless pull. We've seen stars evolve and change throughout their lifetime, all dictated by their initial mass and composition. We've delved into the captivating concept of supernovae, a stellar explosion of such magnitude that it can outshine an entire galaxy, marking the end of a star's life cycle and the birth of something new. This process seeds the universe with elements heavier than iron, contributing to the cosmic dust from which new stars, planets, and possibly life can form. We've explored the theory of white dwarfs, the remnants of medium-sized stars like our sun. These dense, hot cores, left behind after a star has exhausted its nuclear fuel, slowly cool and fade over billions of years, Despite their end, white dwarfs play a vital role in the cosmic cycle of birth and death. We've journeyed into the depths of neutron stars, unimaginably dense remnants of supernovae. These celestial bodies, with a teaspoon of their matter weighing as much as a mountain, are truly one of the universe's most extreme creations. We've peered into the abyss of black holes, the final fate of the most massive stars. These gravitational monsters warp space and time around them, swallowing everything in their path, even light itself. Through these theories, we've seen the importance of stellar evolution in shaping the universe. Every atom in our bodies was once part of a star, and these theories help us understand how we, and everything around us, came to be. So the next time you gaze at the stars, you'll know a little more about their incredible journey from birth to death. From the heart of a newborn star to the final whisper of a white dwarf, the life cycle of a star is a cosmic ballet of creation, destruction, and rebirth. It's a journey that's as beautiful as it is mysterious, and it's all happening right above our heads. As we conclude our interstellar odyssey, let us emphasize the immensity of the universe and its endless opportunities for discovery. However, we cannot continue our explorations without your aid. If Star-Studded Voyage has piqued your curiosity and the enigmas of the cosmos fascinate you as much as they do us, we hope for you to become a member of our community. If you've learned something new from this video, we ask you to show your support by giving us a like. This small gesture from your end can assist us in connecting with more space aficionados like yourself. Feel free to express your queries, revelations, or simply voice your opinions about the stellar life cycle in the comment section. Your feedback is invaluable to us and aids us in producing content that resonates with your interests. If you haven't done so yet, press the subscribe button and activate the notification bell. This ensures that you stay updated with our upcoming cosmic voyages. We have an array of captivating subjects lined up, and we're eager to delve into them with you. Lastly, if this video illuminated your understanding, we recommend sharing it with your friends and family. Perhaps you might ignite the passion within a prospective astronomer, astrophysicist, or even an astronaut. Remember, we are all essentially stardust. Each of us is an infinitesimal fragment of this magnificent cosmic jigsaw. Hence, let's persist in our quest for knowledge, exploration, and admiration of the universe's wonders collectively. Until our paths cross again in the cosmos, keep your eyes aimed at the stars.